Let's read it. 3 points sit on a grid and their coordinates carry an unknown. H will describe the vector from P to Q, pin down H, then prove the 3 points line up. Here's what we're given. The 3 points P, Q, and R, each with H hidden in its coordinates. And the goal, find the vector PQ. Find the value of H that makes it a unit vector. Then show P, Q, and R all lie on one straight line. So here's what we're working with and what we're after. We hold the 3 points, and from them we build the vector, find H, and prove they are collinear. Picture the plane. P sits up and to the right, Q is just below the origin on the y-axis, and R is way down in the bottom left. Here's the idea we lean on. To get from P to Q, hop through the origin, go from P back to O, then from O out to Q. Lay them tail to head. The single arrow straight from P to Q is the sum. So PQ is PO plus OQ, and PO is just the reverse of OP, so PQ is OQ minus OP. That's the triangle law, and it's how we turn coordinates into a vector. Let's shrink the plane to the side and work through it. Part A1. Write the vector from P to Q using H. We use the rule for the vector between 2 points. The position vectors come straight from the coordinates of P and Q. Subtract OP from OQ, component by component. Tidy each row, and the vector from P to Q has components minus 4H and minus 3H. That's this arrow on the plane, pointing from P down to Q. Part A2. A unit vector has length 1, so we set the length of PQ equal to 1. The length of a vector comes from its components, just like Pythagoras. Square each component of PQ and add them under the root. 16h squared plus 9h squared is 25h squared, whose root is 5 times the size of h. Set that equal to 1, and h is plus or minus 1 over 5. But P sits in the first quadrant, so h has to be positive. We keep 1 over 5 and reject the negative. Part B. First swap in h equals 1 over 5, so every coordinate is a number. These are the 3 points with h filled in. From part A, PQ is minus 4/5, minus 3/5. Now the vector from Q to R, subtract OQ from OR. That gives minus 8 and minus 6. Part B, finishing. If one vector is a multiple of the other, the points line up. 2 vectors are parallel when one is a scalar times the other. So we ask, is there one number lambda that turns QR into PQ? Match the x parts, lambda is 1 over 10. Match the y parts, again 1 over 10. They agree, so the same lambda works. So PQ is 1 over 10 of QR. The 2 vectors are parallel. Both vectors share the point Q, and parallel vectors through a common point must lie on one straight line. So P, Q, and R are collinear. Final answers. The vector from P to Q has components minus 4h and minus 3h. For it to be a unit vector, h is 1 over 5. And since PQ is 1 over 10 of QR with Q in common, the points P, Q, and R are collinear.